Hello.
Am I audible?
Yes, sir.
Okay. Yeah. We'll be waiting for others to come, and then we'll be starting in a while.
Yes, sir.
By then, you should revise the things that we did in the last class. Hello, ma'am. Hello. Am I audible?
Yes, sir.
Yes, sir.
And visible too?
Yes, sir.
Okay. Everyone?
Yes, sir.
I'm not able to see your faces.
Sir, I don't know why this is not allowing me to on my video.
Not allowing to switch on your videos.
Yes, sir. It's telling video camera not allowed.
Just like that. Let me see. Okay, actually the host is not with me. Okay, so you all can see me, the screen too.
Sir.
Now, did you get that permission?
Sir.
Actually, one kid didn't come, sir.
Nitish.
Yeah, call him then.
Look, he's trying to join.
Just a minute.
He told us to wait for it.
Okay, can you see the screens? Everyone, can you see the screen? So, am I audible? Tarun, Sankal, hello.
Sir.
Can you see the screen that I've shared?
This shows a bad network, sir. Google Meet. Sorry, so
Actually, this side, you all are clearly audible, and the screen is being presented. Can you see that,
yeah, sir.
Sankal, Tarun? Yeah, Sankal, is it visible? Am I audible to you? Hello, Tarun, am I audible to you?
Sir, your voice is a little bit breaking.
Voice is breaking. Should not be. Can you see the screen that I have shared? Hello? Hello? Hello, am I audible? Everyone there?
Yes, sir.
Clearly? Am I clearly audible to you?
Yes, sir. Yes, sir.
Can you see the screen that I've shared? The presentation slide?
Yes, sir. You have written, am I audible?
Exactly. Everyone, is that fine with everyone? Shall we proceed?
Yes, sir.
Okay. So what we did in the last class? What we did in the last class? Did you all revise? I guess some lag is there from your side. You just refresh your network and then that will be better, I guess. Yeah. So what we did in the last class? It was still
Sir, we
system of units, I guess. Pardon?
yes, sir, we studied about physical quantities and two types of physical quantities: fundamental quantities and derived quantities. What are fundamental quantities?
Exactly.
What are derived quantities? Examples of both of them.
And units,
And what
fundamental and
are
derived units.
fundamental and derived units?
Yeah. So today we'll be dealing with system of units. System of units. Right. So there are like three basic system of units which are required to take into consideration and like when we go for measurement, right? So some common system of units that we'll be considering as are CGS unit, CGS system. I'll be just defining them. CGS system, FPS system, CGS system, FPS system, MKS system, MKS system, and the SI system. Okay, or we just write SI there. So what are these systems? CGS system, FPS system, MKS system, and SI system. Okay. So if we go on definition, the CGS system says that the total full form of CGS is centigram second. Centigram second, right? Centimeter,
Yes,
it gives
sir.
a centimeter. Centimeter for length, gram for weight, and second for time. So the like for fundamental units, the CGS system takes centimeter, grams, and second to be considered as the fundamental units for the
Fundamental
length,
units.
mass, and time respectively.
Yes, sir. Yes, sir.
Fundamental units for length, mass, and time respectively, right? So only these things like are changing for every other system of units. If you go for FPS is foot pound second. FPS is nothing but foot pound second. We generally use the length as the length. We use foot. It is foot. Then for weight it is pound, and for time it is second. Okay, this was used by British. British people generally use this unit, foot pound second. They generally measure the like distance or length with like with the units of foot. They generally measure the weight in terms of pound and then the time in terms of second. In France, it was earlier used as CGS, centigram second.
Yes, sir.
Then you have to copy the second and you have to copy like this. Foot second as the fundamental units for length, mass, and time respectively. Like that, you have to copy for all of them. In
Sir,
MKS, it is meter.
can you talk from the
Meter,
CGS
kilo.
system? So my voice got my Wi-Fi got the
Yeah. So from where you want me to repeat, Nitish?
CGS system, sir.
CGS system. Okay, I'll repeat from there. CGS system of unit is something like it is having the full form centimeter, gram, and second. So in this system of unit, the fundamental like the quantities like length, mass, and time are represented with the units of centimeter, gram, and second respectively. Okay, so there are various system of units. All the system of units are are different from each of them. with the quantity they are measuring. Okay, like in CGS system of units, you measure length with the units of centimeter, weight with the gram, and then time with the second. In FPS system, you measure your weight with pound, your length with foot, and time with second. In MKS system, for these fundamental quantities, you use meter, then kilogram, and
Meter,
second.
kilogram, and second.
Yeah, meter, kilogram, and second. And this is international system of units. International system of units. International system of units. Okay, this was also devised in France only. Okay, it was
Meter,
okay. First you write this down. First you write this down, and then
Meter, mass,
Meter, kilogram,
second. No,
meter,
meter,
kilogram,
mass, second. So, SI unit is. Oh, sorry.
Meter, kilogram.
First, have you
So,
all
then
written
what's
this?
the difference between SI system and MKS system,
I'll
sir?
tell you. You have written all these things.
Foot is a
Sir.
different unit of expressing the distance also.
Yeah. So see here. We use different system of units, na? And generally it was like long ago when we used such system of units, centimeter, foot, pound, or meter, kilogram. What happened after that? It was in a general conference decided among the mutual scientists that like in different region we are using different units. In different region we are using different units of system, right? So different units of system will be causing confusion. Are you understanding that?
Yes, sir.
Like in India, you are measuring 1 meter. In India, you are measuring 1 meter. Uh, Same thing, if you'll go for the same length in British, you have to ask for 100 centimeter. Are you getting it or not?
Sir.
Yes, sir.
Okay. So
Sir, can
it
you
was a
repeat?
point of confusion. Pardon? Pardon? Any doubt?
What did you just tell now? Could you repeat what you told now? Like, what did you tell now?
I told now that if we have different system of units at different places, so there will be a confusion created there. Okay, because
Yes,
we
sir.
cannot measure the same quantity with the same units, right? If you're asking for 1 meter of something in Britain at that time when they were using CGS system of units, so that was a kind of confusion, or FPS system of units. So they would not have like answered you, right?
Sir.
So after that, a conference in a conference, it was decided that we have to create a uniform units standard of units. Okay, so that we can apply that particular unit system everywhere in every fundamental quantities. Okay, and that is called the
It
SI unit.
also differs for items, like so for TVs we talk with about with inches instead of centimeter, foot, or anything. But when it comes to tables or stuff like that, we come to centimeters or meters.
Yeah, actually, what happened after that? Now, initially it was different for different regions. So after that conference, it was decided that we have to create a uniform system of units for every fundamental quantities. Okay, we have to create a uniform system of units for every fundamental quantities that can be applied to all the quantities in every region, and they have to accept that. Understood?
Sir.
Got my point?
Yes, sir.
Okay, let us move forward. So international system of units we have to study, and we'll be applying this international system of units only for every other cases. Okay, so see, there are basically 7 fundamental quantities which we describe. Shall I change to next page?
Sir.
Okay, so there are basically 7 fundamental quantities. Fundamental quantities. And their units. and their units. So first is length. Length is a fundamental quantity. Any doubt there?
No, sir.
Mass. Then we have temperature. Temperature. Then electric current. Current. Then we have luminous intensity.
So these are examples of fundamental quantities.
Yeah, 7 basic fundamental quantities that are there. So, and then at last we have quantity of matter. So these are fundamental quantities. Can anyone give me the definition
So
of
what
fundamental
about
quantities?
okay.
So they can be neither derived nor simplified into simpler units.
Exactly, very good. It cannot be derived or simplified into simpler units, and they don't need any other units to get defined, right? So what is the unit of length in SI unit?
So meter.
Meter mass.
So meter mass is kilogram, time is second, temperature is
Second.
Very good.
What is that?
temperature is degree Celsius, electric current is
No, it's Kelvin.
Oh, what?
We measure temperature in Kelvin, not degree Celsius.
Oh,
It is not the
okay.
like SI unit. It is not the standard unit. Electric current, anyone?
What?
Huh?
Maybe what?
No, that is for power. Electric current is ampere.
Okay.
Yeah.
Only write this with small a sign because capital A denotes with the scientist. Luminous intensity, that is how much amount of light is coming out. So that is measured in candela. You must not have heard this term,
Yes.
but it is candela. Quantity of matter, you have studied this.
Mass. Oh wait, no. Volume. Oh wait.
No,
Quantity of
Matter.
it is something related with chemistry.
uh,
No, sir.
Have you heard about the term mole?
What, sir?
Mole, M-O-L-E, mole.
sir.
Not yet.
No, sir. No, sir.
M-O-L-E, mole. Avogadro's
No,
number.
sir. We didn't
Nothing
learn
like this?
about.
Okay, so you must be.
Sir,
learning
I
about this
think
in class
I do
9.
remember mole, sir.
Okay, mole.
Like we read mole
Mostly after
somewhere.
studying, I think you'll be studying this in class 9. It is mole, quantity of matter. Okay, how much quantity that is there? So 1 mole represents a very huge number. 10 to
Sir,
the power
I
25,
heard it.
6.02.
I heard it. Like I.
Okay, that's good. That's good. So 6.022 10 to the power 23. 1 mole includes 6.022 into 10 to the power 23 items in 1 mole. Okay.
So the unit, like the symbol for mole is just M, sir.
Generally, we write mole like. Okay, I'll writing the symbol also. For meter, I should write here meter. I'll write the symbol beside it.
Kilogram.
Meter. It is M. Kilogram is kg. Second is S. Kelvin is K. Ampere is A. Candela is CD. And mole is MOL, mole. Like this. This is a symbol. Okay, so you all write it down quickly.
Yes. Sir.
Sir, Sir? Hello, sir.
Yeah, any doubt?
So when will you have to, when will you have the need to find the quantity of matter on real life?
Like you want to relate, or you want to ask the same unit when we are using mole now.
Sir?
You want to ask that when do we use mole term now?
Like in our daily life.
Daily life. Okay. So there's a chapter in chemistry. Basic, like stoichiometry kind of word is there. If you have heard that term, generally we represent number of atoms in that term. Okay. See, in any material, if we say that oxygen is present in air, so huge amount of atoms are there, or molecules of oxygen are there in air. Okay. So like it's really huge. It is of the order 10 to the power 23, more than that. So generally we use mole term there to represent the number of atoms, to represent the number of molecules or compounds in chemistry. So how much number of atoms or any quantity is present in any area or in any
Excuse me,
chemical.
sir.
So that we
Yeah, sir, candela is COL, right?
Yes.
CD, candela CD.
CD.
My mistake. Sorry, I should write like this CD. Written everyone?
Yes, sir.
Okay. Moving to the next term. Shall I change the page?
Yes, sir.
So on.
Oh. Written everyone?
Yes, sir.
Yes, sir.
Okay. I'm changing the page.
Yes, sir, finished.
So see here, basically two more quantities are there. Two more units are there. These are called supplementary units. Supplementary units. Why they are called supplementary units?
So they're not used that often.
No, not exactly. See here. One is plane angle, and second one is solid angle. Second one is solid angle. So plane angle has got the unit of radian. Angle we generally not measure in degrees. It is radian, the SI unit. And solid angle is steradian. See, plane angle is generally that is formed in 2D. Like if you are eating a pizza, so pizza one pie has got some angle, na?
Yes, sir.
So that is plane angle. Everyone, is that clear?
Yes, sir. So
Yes,
what's
sir.
the ingredient, sir? Solid angle.
Pardon?
So a
steradian
plane
is
angle.
like have you ever went to buy a watermelon?
Yes, sir.
Yes, sir.
Do you generally check, like you ask the watermelon seller to cut the watermelon and then check inside whether it is good or bad?
Yes.
Yes, sir.
They generally cut it like this and give you a piece of cone, something like this.
Yes.
Yes, sir.
Everyone? So there will be some angle inside this cone, na, and that will be a 3D kind of angle.
Yes, sir.
That is called steradian.
So plane angle
Are you
is
getting my
2D, solid angle is
Uh-huh.
3D, sir.
You got it. You got it. Plane angle in 2D is radian, and since solid angle 3D, you consider it as steradian. Got it?
Yes, sir.
Yes, sir.
Okay, I'm not going to deep with that, but you just need to know this, right? Write this down fastly. We have to cover a lot of topics today.
Yes, sir.
Done?
No,
Yes,
one
sir.
second, sir.
Done, everyone?
One
Yes, sir.
second,
Yes, sir.
Okay, take your time, no problem.
sir. Done, sir.
Okay, done.
Yes, sir.
Yes,
Right.
sir.
Okay. So next, what we have to see here is that there are certain prefixes that we use. Okay, certain prefixes that we use. Prefixes is what? That are used before any term, right? So that are called prefixes. There are certain prefixes
Like,
that I'll be telling you. I shall tell you here only. See,
so like
Prefix.
what's a prefix in the sense?
I'm telling you. You must have heard this, and its meaning I'll be telling you. So see, there are lots of prefixes that are present inside a book. I'll just tell you that those prefixes that are used generally. So if I say that I'm 10 to the power 3. So for 10 to the power 3, what do you generally use? You use kilo, na?
So, yes, sir.
You must have heard this. 10 to the power 6 is nothing but mega, right? So if I want to write
Then beta,
one,
alpha.
no, not like that. See here. If I want to write 1000 meter, instead of that, what do I write? Why I write now 1 kilometer?
Yes, sir.
Yes,
Are you
sir.
understanding that? So these
Yes,
are the
sir.
prefixes. See, I use the word prefix now.
Yes, sir.
Yes, sir.
I use the prefix here to denote 10 to the power 3. So now it becomes what? 1 into 10 to the power 3 meter. So that will be 1000 meter. This is how it is written. 10 to the power 6 is written as mega, right? Then
Yes.
if it is 10 to the power 9, so it is giga. Where have you heard the term giga? Tell me.
No, I don't know.
Yes, sir. Yes, sir. I think I learned this in third standard or fourth standard, where like the units after kilo.
Like that you have to study. Have you ever heard the
Oh,
term
yeah.
giga?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Where?
I also remember, sir.
Where?
Sir,
So,
we
like,
never wrote this in real
Huh?
lives.
it's
No
like
one used-
centi. It is like a milli, centi,
Yeah. That will be
meter,
used. That will be used.
Micro,
kilo,
milli, centi,
mega,
meter, kilo,
giga,
mega,
like
giga.
I'm
after that.
asking, have you heard
Goes
the
on
term
like that.
giga?
Yes,
Have you
sir.
heard the term giga?
Sir.
Sir, no one really uses it in like the real life. So
Yes, sir.
it's
Like
very
no
rare
one
to hear.
really.
See here. You must have been connected with the internet, right?
Sir.
Sir.
There will be some kind of speed with your internet, and they generally provide 1 GB per second or 2 GB per second, something like that.
Yes, sir.
Yes, sir.
What is GB?
Gigabyte.
It's a gigabyte.
Where you get the term giga? And that is the prefix. It
To the power
denotes
of
10 to the
9.
power 9 bytes. Understood? If it is
Yes,
MB,
sir.
MB is how much?
Sir,
Megabyte.
giga is 2
Megabyte.
kilometers, sir. No, wait.
Oh,
No, wait.
10 to the
10
power
to the
of 9. That means there are 9 zeros before 10.
Yeah, exactly. 9 zeros. Okay. So that is how it goes. Okay. And then when we have 10 to the power minus 1, so it is
Means
deci. If it is 10 to the power minus 1, it is deci.
sir,
Go on.
it means 10 billion bytes, sir. 1 gigabyte.
Yeah. I'm not knowing that if you are calculating it exactly or not. So if it is 9 zeros, 3, 4, 5, 6, 7, 8, 9 zeros and
Yes,
then
sir.
1.
Yes.
Okay. 100, 100,000, 100 million, 1 billion.
Exactly 1
Okay.
billion.
Yeah. So 10 to the power minus 3 is called milli. And then you have 10 to the power minus 6.
That's 1 billion.
No, it's
I'm
meter.
erasing all these
Wait,
things.
no,
which
wait,
I've
wait,
written.
wait.
I'm erasing it here.
The
I'm erasing here and
gigameter.
I'm writing. You have written this part now?
No, so I'm writing the prefix.
This one, this right one, this kilometer, this one.
Yes, sir.
Yes, sir.
These things you must have
So
written.
one second,
Okay,
one
I'm
second,
writing
one
it here.
second, one second.
Yes.
So it is for 10 to the power minus 6, it is micro. It is
Yes, sir.
micro.
What
10 to the
is
power minus 9 is
DE?
micro.
What is
Deci.
D?
See, this one. This is DECI. DECI.
Yes, sir.
Deci.
So after nano,
DECI.
there is nothing, right, sir?
There are basically.
So there is
After
micro,
nano,
right,
there is
sir?
what 10 to the power-
Micro, then only
micro
nano.
is 10 to the power minus 6. Nano minus 9 10 to the power minus 15 is called femto. But we
So
generally
there is
don't use
something.
these terms.
There is something where 10 to the power of negative 27, sir.
There are
10 to the
there are
power of
terms for
negative
that, but we generally
27.
don't use that.
Huh.
But we generally don't use that. We use around this much. 10 to the power minus 12 is called pico. But what we use in daily life, what we have in daily calculation, you must be using all these terms. You should know. So that's why I wrote till here only.
Yes, sir.
Written.
1 second, sir.
I'm writing.
Yes, sir. Done, sir.
Written everyone.
Yes, sir. Dance. Yes, sir.
Okay.
So 1
Yeah.
second.
Now
one
we'll be
second. So what is 10 to the power of 6?
10 to
Mega.
the power of it's mega.
So 10 to the power of negative 15.
Negative.
Nano.
15. No, 10 to the
Oh,
power of
femto.
negative 9 is
Femto.
nano.
If it is minus 9, it is nano. Femto is
10
minus
to the
15.
power is
Yes, 15.
femto.
Pardon?
So, yes, sir. Nothing, sir. Femto.
Okay?
Yes, sir.
So see, now we'll be seeing that different units of different fundamental quantities. Basically, we'll be seeing that what are the units for length, what are the units for weight, what are the units for time generally, right? So before that, what is
Sure.
SI unit? So SI unit.
So it's a
SI
standard
unit.
The
international unit.
standard international unit.
A meter was we have to
Standard
define in SI
international
unit. You have to
unit of
define
length.
meter. We have to define 1 meter, 1 second, and then 1 kg, right? So a meter was
Yes, sir.
originally defined in it was the year 1889, I guess, as distance between two marks drawn on platinum, iridium, which was an alloy. What do you mean by an alloy?
It's a mixture of two or more metals.
Exactly. It is mixture of platinum and
Two
iridium
or
with
more.
90%. Yeah, 90% iridium. That's good. You know these terms. 90%.
Yes.
10% iridium. It is not 90%. 10% iridium and 90% platinum. 10% iridium and 90%
90% platinum.
Platinum.
Yeah. 10% iridium and 90% platinum. Right?
Yes.
Rod
So,
kept at 0 degree Celsius, which was kept in international Bureau of Weights and Measures. Bureau of
it's an international what?
Weights
International
International
Bureau
Bureau
of
of Weights
Weights.
and Measures.
This is there in the book.
Yeah,
It's okay.
at Seviers near Paris. You know why it is kept there? Because the temperature there is said to be ideal temperature. No, very much fluctuation does not occur there. The temperature is ideally stable there. That's why it was kept there. Okay, so these alloys are generally independent of quite independent of change in temperature, because it with the heating, the expansion is there.
So
With the
in
cooling, the
International
contraction is
Bureau
there.
of Weights, it's always 0 degrees Celsius.
Yes.
No, not exactly 0 degrees Celsius. It should be the
What?
standard temperature. Okay, the standard temperature.
So it should not
Standard temperature
go
is around
too
25,
far
27.
from the original 0 degrees Celsius, or the alloy will
Pardon?
get damaged. Like if it goes
No, nothing like
so
that will
far
happen.
from
Alloys are made generally of such a material that are quite independent from the change of material. They do not react to the change of temperature. Okay, so
then
they
why
are
are they kept
good
at 0 degrees Celsius?
If
see,
it is
it
if
not
it is
exactly
heated, it
kept
will
at 0 degrees
expand.
Celsius. Huh?
Like if there is more degrees
See, the
Celsius,
thing
it
is
will
that it is
expand
kept
and
at
it
0
won't be
degrees
1
Celsius.
meter.
It is kept at 0 degrees Celsius because the temperature is maintained. Because we have to then see that at 0 degrees Celsius, this is the length. Okay, and that is uniform. That is not changing. That 1 meter is still 1 meter. But generally, the
Yes.
scale that you have may expand or may contract according to the change in temperature.
Yes.
Okay, so that does not give the exact or correct answer. So that is why it is kept at constant temperature. 0 degrees Celsius provided there.
So what
Okay,
did
it
you
is
write
also
after
somewhat
measures at, sir?
after measures
Measures at
at CVS, SEVRES,
SE?
CVS near Paris.
Oh. Yes.
Written
Yes, sir.
yes, sir.
according to this, different units of length were taken out or found out. So shall I move to the next page?
Yes, sir.
So can you just spell that
So what first
SEU? Is it SEURS?
SEVRES,
SEVRS. VRES.
SEVRES, CVS near Paris.
Yes, sir. Done, sir.
So after this, we have to move to the different units that was devised for length, and the first of them is centimeter. What is the unit relation of centimeter with meter?
100 centimeter is equal to 1 meter.
Okay, it is 1 by 100 centimeter. 100 centimeter is 1 meter. Okay,
Yes.
this is the relation. Or 1 centimeter is 1 by 100th of a meter. So that for the platinum iridium scale, if it is kept there and the mark is made, this length is 1 meter. If we say, so when you divide this length by 100, you get the mark, and that is said to be 1 centimeter.
Yes,
Understood?
sir.
Then what do we have?
So wait,
Then what
no.
do we have?
Yeah, kilometer.
Millimeter.
Kilometer.
Millimeter. We'll
Kilometer
see
comes
that, we'll
after
see that.
meter.
1000 millimeter is 1 meter.
Meter, because
1
every
meter.
10 millimeter is equal to 1 centimeter. 10 into 100.
So 1 millimeter is equal to 1 by 1000 of meter. Any doubt there?
No, sir.
If you want the definition of millimeter, you will say that it is 1,000th of a meter, right?
Yes, sir.
1,000th
Of a
of a meter.
meter.
And it is 100th of a meter, like that it goes. Third one we'll be seeing is kilometer. Kilometer is nothing but 1 kilometer
1
is
kilometer is equal to 1,000 meters.
1,000 meters, right? then we
Yes,
have some
sir.
other units also. Nanometer.
Yes,
Nanometer.
megameter,
So
nanometer.
10 to the power 9, 1 nanometer is 10 to the power minus 9 meters.
Yes, sir.
Yes, sir.
That means 9 more zeros should be
9.
added.
No,
Sir,
Nine
if
divided, it should
sir,
be
sir,
divided with
if
this much.
if
no,
This much
1
SETI
meters.
is
million. Oh, wait, 1 billion. 1 billion. 1 by 1 billion meters. Sir.
there
Yeah,
should be 9 zeros after 1.
1 billion.
1 billion nanometer.
It has to be
Yeah.
divided with this number. Then we have micrometer.
Sir,
Micrometer is 1 by
so 1
1
million,
by
1 million millimeter, 1 million.
Million. That's good. It has to be divided with that number.
oh yeah.
Write this down, everyone.
Yes, sir.
So after kilometer, they'll always give those powers.
Pardon?
After kilometer, will they always give those powers? Minus
No,
9,
see,
minus 10.
powers are different kind of things.
Fem,
You can
so
write
It's only
system
that for
also
nano,
or
micro.
sir,
you
1
can write in these
zillion
terms also or in
femto.
these terms also.
Excuse me, sir.
Like that it can also go. If it is femtometer, so it is 10 to the power minus
15
15 meters.
zeros. 1 by
15 zeros
zeros
means
divided
zillion,
15
sir.
zeros. Huh?
15 zeros means zillion. 1 zillion.
Yeah, 15 zeros is huge. It's kind of billion. Not exactly billion, I guess. No, 15 zeros is not 1 billion only.
It's not 1.
More than
Sir,
billion.
how 1 billion, sir? 9 zeros is 1 billion.
No, sir,
10
it's not
zeros is 10
billion.
billion. 11 zeros is 100 billion.
zeros is
12
1
zeros
billion.
is 1 trillion. 13 zeros is
Ah,
10 trillion. 14 zeros is 100 trillion. 15 zeros is
15 more than
1 zil.
No, it's not
Yeah.
zillion. After trillion, it's not zillion.
Yeah,
So written this one.
1 sec.
Yeah, it's quadrillion years.
Oh, sorry.
Maybe.
Bruh, you forgot 2 more units. The quadrillion,
Sorry.
quintillion,
So, quadrillion, quintillion. Yeah.
and then I don't know. After that. Yes, I'm writing, sir. Once.
We usually don't see bigger units than trillion.
But there are
My
the,
IQ.
when we measure the length of an atom, the radius of an atom, atoms are so small that they have the radius of around 10 to the power minus 15 units.
10 to the power of minus 15.
So I thought they were smaller,
Minus
sir.
15,
So I thought they were
15.
smaller, sir. I thought they were
Yeah,
like
that's
10 to the
what
power of
I-
negative 27.
They are so small that they have the unit of radius 10 to the power minus 15 meters order.
But that's so
Okay,
big,
see,
sir.
they are so small.
But
Sir,
an
I thought-
atom, I thought it was smaller than that, sir. I thought about 10 to the power of negative something like a big number. Or
Sir,
So this is this much. Written, everyone?
it's almost, sir.
I did fast.
Yes, sir.
So it's actually 10 to the power of negative 10 meters, sir.
Pardon?
So it seems it's 1 into 10 to the power of negative 10.
Even that is there. That is there. But we
That's
generally
also
do not use any generally frequently do not use that. That's why not a particular name is given to that.
So it's just
10 to the power minus 10 if I
1.2
talk about
into
it,
10 to
Armstrong.
yes, sir. Armstrong
If it
is
is 10
a
to the power
smaller
minus 10
unit.
meters.
Yeah,
It
it's
is 10 to the power
smaller
minus 10
than
meters.
nano.
But bigger than
It
femto.
is smaller than
No,
nano,
it's
right?
not.
Because it is getting divided. So when you increase the number in denominator, it becomes smaller. So smaller than nano.
Yes, sir.
Right? We are moving forward, right? I'm changing the slide now.
Yes, sir.
1 second, sir. 1 second.
Yes, sir, you can change, sir.
Okay. Now see here, we have some bigger units of length also. Bigger units.
So mega,
Bigger units like
giga.
this. No, bigger than that. So we have the first one, 1 light year, or 1 astronomical unit.
Oh my. Yes, I forgot.
Sir.
Astronomical unit.
So
is
what was the
astronomical unit?
last smallest unit you said? So 10 to the power of negative 10.
Armstrong.
10 negative. Armstrong minus 10.
Yes.
It is the mean distance between
What's the distance like? How much meters is one astronomical unit, sir?
Earth and Sun. So 1 astronomical unit is basically the mean distance between Earth and Sun, and that has the value of around 1.496 into 10 raised to the power 11 meters. So Sun is this much, averagely this much. Sometimes it is closer, sometimes it is far away. So averagely, Sun is around this much far away from Earth. So this is 1 astronomical unit, generally used by astronauts or space work scientists like that. Then we have light year.
Yes, sir.
So
Then we
it's
define
1.496 into 10 to the power of 19 or
11 meters.
11.
11 meters, 11. Okay, 1 light year, then we have to define.
So the time taken for a light, like the time
It's
taken
not
for
the
a
time.
light.
No, it's not time. It's
If
generally
if we
distance.
say when we
length.
say
The
an,
distance covered by
when
light
we
within a year.
say an object is 1 light year away, they mean that
Mhm.
the object.
It takes a light
that-
1 year to travel that much time.
Yes.
Exactly. That light takes 1 year to travel to that particular object. So light has a speed of 3 into 10 to the power 8. Okay. The
Yes,
speed
sir.
of light is around 3 into 10 to the power 8. This is the speed of light. And if you take
In
1 year
meters, sir?
distance, so 1 year has got 365 days and 1 day has got 86400 seconds. So if you multiply this, you get the distance traveled by light in 1 year, and that is approx 9.46, I guess. Yeah, 9.46 into 10 raised to the power 12 kilometers.
So we can
So-
find the we can find the distance of the sun if we do 3 into 10 to
Case
the
of
power of
light also we
8.
can find.
Yeah, like
It's
we
In
can.
case
an
of light, then also
astronomical
we can find.
unit. Oh, the light year between us, Earth and Sun.
Okay. Astronomical unit is the mean distance between Earth and Sun. That is this much. Light year
So
is the
you
distance traveled by light in 1 year.
So you've written it in kilometers, sir, or transformed the light year into kilometers.
Okay, this is what you want in meters.
It's so it's just 12. It's 10 only is meters, sir. It's 12 is only kilometers. Sir. No wait, 15 is meters.
15 meters.
Fif-
If you want to write
So,
it in meters, it is 15 meters.
yes, so the 10 will transform into 15, right? Sir?
You have to multiply with 10 more, 1,000 more to get it into meters.
Yes.
Right? Then we have one more term.
So the
and that is parsec.
mean formula for the light year in meters is 9.46 into 10 to the power of 15. That's it.
15 meters. Yeah. And then we have 1
Yes.
parsec. Okay. It is the distance between.
So what's the number
Distance
you've given after 365, sir?
86400. It is the total seconds in 1 day.
Oh, okay.
So what?
Total seconds in a day. Seconds.
How many
86500.
86400.
Okay.
Why 86400?
So one parsec is bigger than light years. I mean longer than light years.
Yeah, yeah. Light year is bigger, and parsec is biggest of all. Parsec is biggest of all. Distance from where the semi.
We'll give it in meters, sir.
Pardon?
You will give it in meters, sir.
Yeah, I mean
Excuse me,
meters,
sir.
meters. Semi
So
major
it's this.
axis.
Excuse me, sir.
Yeah.
So the gravitational attraction of the black hole is stronger than the speed of light.
Yes.
That's why the speed of light, if it gets inside, then it cannot come out, and that's why you see a black hole to be black.
There's 0% of light.
Hmm.
So one parsec is like 3.26 light years.
Ah. Subtends an angle of 1 second.
So what is AU?
Astronomical unit.
Astronomical
So
unit.
what happens there? What happens there? 1 parsec is calculated like this. Generally, you have 1 AU distance. Okay, 1 AU distance. You keep 1 AU distance. Okay, and then you have to focus, join its 2 points, and then it should create 1 second angle. 1 second angle. Okay, angle generally you must have measured in degrees, right? Angle degrees,
So,
like rupees, and then we have paise, na? Rupees for
yes,
substitute, we
sir.
have paise. In the same way,
Yes, sir.
degrees.
Smaller unit.
In the, after that we have minutes, and after that we have
So
seconds.
Yes,
so
sir.
like one
You
AU
have
is
to
there.
create an angle of 1 second. You have to create an angle of 1 second for a distance of 1 astronomical unit. So this length will be your parsec. This length will be your parsec, and that is around 3.08 into 10 to the power 16 light years. 1 minute.
So I didn't understand what a parsec is.
I was gonna say the same thing.
Yeah. What's that after IAU? 1 AU?
Pardon,
Hmm?
after
One
what?
AU.
After 1 AU, what did you write, sir?
After 1 year, subtends an angle of 1 second.
So I have a doubt.
Subtends an angle
So
of
I didn't understand the parsec.
Parsecs, even
parsec.
amazing.
What exactly parsec is? So see here,
Yes,
basically
sir.
1 parsec is we have to make one line. We have to make one line, 1 astronomical unit a line. Okay, the distance of 1 astronomical unit. Okay, and then we have to join the points. We join the two end of the line with one single point to make a triangle, right?
Yes,
And
sir.
after
But
that,
Yes,
the
with
sir.
how
length,
much? Yeah, but how much should that angle be, sir?
it should be 1 second. 1 second.
No, sir. The angle between like
This
I'll
angle
just.
should be 1 second. This angle should be 1 second. This angle 1 second.
What do you mean by 1 second, sir? Like
That's what I
I'm
told.
saying
That's what I
degree.
told. See, clearly listen properly. I am repeating it for the second time. Like we have the smaller unit of rupees as paise,
Yes, sir.
right? Similarly, for the smaller unit of degrees, the angle, we have minutes, and the smallest unit we have seconds.
So a smaller unit of a degree is minute.
But how are
Yeah,
they
yeah,
related, sir?
exactly. See, it is not that minute of time. You don't have to relate them with time. Both are different things. Both are different things. You don't don't have to relate it with time. Understood? This minute of degrees is different from minute of your time, but the term
Oh,
is
yeah,
same.
sir.
So,
Okay,
so
you
this
must have
second
said
and
that
this minute is different from the time second and time minute.
Yeah. That is different.
Yes, sir.
Okay, just understand.
So you
this
have to
much
take
now.
the smallest unit of a degree, sir.
Smallest unit of a degree is 1 second.
So that's what you have to take to.
But why can't it be
Ah.
millisecond, microsecond, etc.?
Second is the
No,
smallest
it's
one
not
for
like that.
degree.
It's already been devised by the scientists. We cannot change that. We cannot change that. Okay,
Yes, sir.
Yes, sir.
good. So you write till here.
So,
And yeah, one more thing. 1 parsec is, if you compare 1 parsec, is 3.26 light years. 3.26. If you multiply 1 light year with 3.26 times, you get 1 parsec, right?
Yes. So 1 parsec is when one astronomical unit is this is one the scale is a one astronomical unit, and
Yeah.
two lines from the both ends of the astronomical unit
You have to join.
join to form a triangle, and the distance from the one end of the astronomical unit to the point is the parsec.
And that timeline should be 1 second only.
Yes. Okay. Now I understand.
Got it? Everyone?
Yes,
Yes,
sir.
sir.
See, so these were the big units. Similarly, we'll be seeing that unit time also in the next class. Okay, there is one lunar month. See, generally, what do we measure as time? Seconds, hours. Okay, and then minutes, and there are then bigger units. Like earlier, we used to there is one case of lunar month. Okay, there is one case of lunar month. What is lunar month? So generally, in ancient times, there were different peoples, and they used to represent times or read or study times with the movement of moon. Okay, so moon in that case, the calendars were based on the phases of moon and sees as seen from the earth. Okay, 1 month is the time between one lunar cycle, 29.5 days. Okay, one lunar
Yes,
cycle
sir.
is from one full moon day, then half moon day, then again full moon day, like that it goes, isn't it?
Yes, sir.
Understood one lunar month? We'll
Yes,
study this
sir.
in the next class. Lunar month will be seeing detail. I just told you that there are different units of time.
Lunar month is a
Seconds,
unit
minutes,
of
and hours.
time, sir, or distance, sir?
Pardon?
The
Lunar month is a
the unit of
unit of
distance.
time or distance?
Time.
Okay.
It is
Okay.
the 1 month cycle. In 1 month cycle, we have one full moon day, and then we have half
Yes, sir.
no moon, and then we have full moon.
Yes, sir.
So that was calculated to be 1 month. It took 29.5 days around. So earlier we used to calculate time in that respect. So it was the system of units of distance we studied today, and then in the next class we'll be studying the system of time. Right?
Yes, sir.
Written, everyone?
Yes. Yes, sir.
Yes, sir.
Sankalp written, Tarun written.
Yes, sir.
Last
Yes.
word, sir.
Okay, so shall we end the meeting here?
So 10 to the power of 16 Ly. What is Ly, sir?
Where 10 to the power 16 Ly? Oh, sorry, it is
It's
meter.
Ly
Here
light.
it is
Unit of
meter.
passing. I think it's
Here
meter,
it is
sir.
meter. Here it is Ly. Change it if anyone has written it incorrect.
Yes.
Here it is meter. Here it is Ly. So 1 parsec, if you compare with light years, it is 3.26 times. Done?
Yes, sir.
Tarun?
Yes, sir. I finished.
So
Okay, then.
in one light year, the light travels one quad. Sorry, 9 point
Light travel speed.
9.46
For 1 year.
quadrillion
Into
meters.
one quadrillion, which is 9
9.46
quadrillion,
quadrillion.
460 billion, no,
Trillion.
trillion.
460
That's it.
trillion meters.
That's it. 9 quadrillion,
Okay, then.
460 billion.
Revise the things and then come for the next class, right? I'm ending the meeting here.
Yes, sir.
Bye, everyone. Hope you like the session.
Thank you, sir.
Thank
Thank you,
you.
sir. Bye.
You again wrote 3.26 Ly, sir.
Yeah, that is light year. That is like 1 parsec. When you compare with light year, it is 3.26 times.
Thank you, sir. Bye, sir.
Okay, then bye.